So I'm David Henkel Wallace. I'm the CEO and co-founder of Blue Dot Change. And we're a company whose objective is to work on climate repair. And specifically, we are working on the removal of methane from the atmosphere. All the methane that comes from is a result of human activity.
And can you just talk us through the kind of the value add line that you have on your website about to cut atmospheric methane by half?
So our objective is to cut the amount of methane in the air by half by the end of this decade. And then one thing about methane is that it's always being emitted and you can't stop it. We've heard about emissions reduction. Very little methane emissions reduction is actually possible with methane. Most of it comes from swamps. Who's going to put a catalytic converter on a swamp, right? Comes from farming, agriculture, dumps. These are all things that people need, and they're emitting methane. So this is a project where we want to remove the methane because it is so dangerous to human life, and then we need to continue working on that indefinitely, because it's going to continue to be emitted at greater levels than it was before humans industrialized.
Could you just explain in layman's terms the kind of vicious cycle that we have as the climate increases, then the thawing increases, the methane increases?
Okay, so before we started burning fossil fuels in roughly 1750, methane was coming from swamps, biological actions, peat bogs and such, and it lasted in the air maybe a dozen years. And so as it was continually being produced, it was over time being removed. And that left a lovely blanket to keep us warm. Methane turns out to absorb heat. And so it's like having a blanket on the bed, right? You're sleeping at night, you do want to have a nice comfy blanket. The problem is, as we started generating more methane, both directly from fossil fuels, because natural gas, for example, is mostly methane, comes out of coal and such, but also indirectly as we started increasing the amount of farming we did. We started essentially putting more blankets on the bed, right? And because humans are producing it faster than the natural processes can keep up with it. And now, over the past few years, as the world has become hotter, we're finding areas such as the Arctic and the Siberian tundra melting. Well, and that Siberian tundra is frozen ice and vegetation. So as that's released with methane mixed in, so it not only releases the trapped 20,000-year-old methane, but it also starts releasing new methane generated from this old vegetation. So we have a problem where that's curving up, and we need some way to get ahead of it. And what we realized, we learned actually through a guy named Peter Fikowski who found this out, is that we can actually accelerate this natural process I talked about of removing the methane, and therefore we can speed that up until the levels get down to a healthier area, and then just speed it up a smaller amount to keep up with what humans are doing.
Slightly. Could you talk us through the process in layman's terms, what it is, the process that
right.
works?
Well, let's talk about the ocean. The ocean covers 3/4 of the surface of our planet. And anyone who's been in the ocean knows it's full of salt, salt is made of sodium and chlorine. So at the top of the ocean, there's the waves flick up and make a little spray. They also put up chlorine ions. That's chlorine atoms. And this was theorized and then was proven through some experimental work in Europe about over the last decade. And that chlorine, plus natural other chemicals that occur at the top of the ocean, NOx's and such, breaks down the methane. It shatters the molecule, I guess is the best way to think of that. You get two H2Os, two water molecules and a CO2 molecule. So this is what nature has been doing for, I don't know, millions of years. It's just not sufficient to keep up with what we're doing to the atmosphere. So what the atmospheric scientists figured out is that, so the French scientists figured out a second aspect of this, which is you may know that the wind picks up dust. For example, it picks up the dust from the Sahara, blows it across the Atlantic, and that fertilizes the Amazon. In fact, it's the iron in that dust that fertilizes the Amazon. Well, it turns out that iron acts as what's called a catalyst. It helps to speed up this ocean-going reaction. Okay, so a catalyst is a kind of chemical. In this case, it's a natural chemical that participates in the reaction and then goes on about its business afterwards, where it can do that again on a different molecule, a different case of methane, molecule of methane. So what we are working on is sending these iron chlorides over the ocean, just in the air about 20 meters up. And the way we want to do that is by working with ships, because it turns out the ocean is full of ships that are already traveling in the open ocean. We don't want to do this near land, we want to do it over the open ocean. And so the idea is to spray this catalyst into the plume that comes out of the ship. That's up 20 meters, like I said, above the water, can travel for hundreds of miles. Since it's a catalyst, it can keep breaking down methane as it goes until the rain washes it into the ocean. Right? And where some of it ends up anyway, the same process happens when the wind blows this dust across the ocean. So basically, we're helping nature do what she already wants to do, but just do more of it to compensate what all of us are doing when we heat our homes or otherwise use methane.
Can you talk about, not necessarily at scale, but what you've just been talking about, that's been kind of tried out practically? Could you talk about that?
All right. Are my answers too long? Am I too wordy? Would you like me to be briefer? To be more bite-sized?
A little bit, yeah. But I mean, what you've used so far is great.
Okay. I don't know if you're giving too many details or you can't edit it down properly to say what you want to say. So, okay. So you were asking...
Yeah, I mean, what you just described, was that taken out and tried in practical terms to get proof of concept, as it were?
Yes, there's good science behind that. There's been work on this, analyzing the salt spray that's done in salt pans in Germany, as well as work on this catalytic process that was done in Germany. And then there's a team in Denmark who is actually trying it out in the lab, getting good results, where they spray this compound into what's called a smog chamber. That's how you create the atmosphere in the lab. And you measure the amount of methane that was there before you did it, and you look at how it comes out. Now we have a little bit more. We have to go through a process. Oh, sorry. Actually, I should just stop and answer your question. Sorry.
Oh, no, that's fine. So you, just real briefly, you talked about essentially smashing the methane molecule. Is there any byproduct from that that's toxic?
Well, okay, so by the way, this entire reaction, chemical reactions require energy in or out. And the energy for this comes from the sun, by the way. This natural process, the chemicals are available in the atmosphere, and the ultraviolet from the sun, which is a very energetic energy. That is what provides the energy to break the methane down. So the methane, one methane, which is called CH4, that's carbon and 4 hydrogens, it turns into 2 H2Os, that's because taking oxygen out of the atmosphere, that's 2 water molecules, and it turns into 1 CO2 molecule. And that's what nature's been doing all along. So sometimes I talk to people about this, and they're like, "Oh, you're getting a CO2 molecule out of the end of it," and that's going to happen anyway, even if the nature got around to hitting that particular molecule. But more importantly, is how dangerous methane is. Okay, there's I think 400 parts per million of CO2 in our atmosphere. There's only 2 parts per million methane in our air. Should be about 750. So we've almost tripled the amount of methane in the air. That methane, the IPCC reported this, is caused a third of the temperature rise that we see. So just that tiny amount. So following this natural process, getting a little CO2 molecule out. I mean, of course, we need to get rid of all our CO2 molecules. That process will reduce our temperature rise dramatically, and that will give us more time to work on some of the other hard problems that we need to work on.
Great. Why are you a private company, and what are the challenges that you've faced?
So this is not a one-person project, right? We need to get people together to do stuff, and people have developed different ways to work together over the years. We've got government, which is good at some tasks, very necessary for those tasks. We have NGOs, for example, people who get together, have a common interest, and do things. And then another common way is a for-profit company. Now, I've used in my past for-profit company as a way of developing and expanding a social issue. What I find is that a for-profit company, which is not the only way and always the best way to do things, but is good for something like this, it lets you work, for one thing, it lets you work with people who don't share your goal. If I need a scientist who's an expert on exotic ceramic nozzles, who perhaps is uninterested in climate change, she might still come and do some work for us. Interesting work, and we get the value. Second thing is that it's hard to fund long-term projects on grants, which NGOs require and government works on. Whereas if you can find a way to create a value for someone, they're going to want you to succeed, and they will help you succeed. Because ultimately our goal is to get rid of the methane, and it's very abstract. You can't taste it, you can't smell it. We're all breathing it into our lungs all the time, and we don't notice. So by making a concrete value, we can actually get get assistance from other people. So I found in my life that this is a good mechanism that can also be very effective at idealistic projects. And this is ultimately an idealistic project.
What are the challenges that Blue Dot has faced?
Well, there are engineering challenges, of course, because we want somebody to operate on a boat in the ocean, in an ocean environment, boats moving, and actually, because the people who run these boats are our partners, we need to make sure that we can resupply it and keep it running without interfering in any way with what they do. But those are what they call known unknowns. Those are just they're in the engineering domain, not the science domain.
Actually, I'm sorry, I'm going to use that, but could you just talk about any partnerships that you have with, is there like Maersk or somebody, there's some ocean-going organization that you're in the process of collaborating with?
We are working with a ship company. We've talked to a bunch. So one of the very first things I worked on was trying to get a partnership with a shipping company, thinking that that would be the most difficult part of the project. Turns out that they are under a lot of carbon emissions pressure, and we're very interested in, everybody we talked to was very interested in having an opportunity to participate. So we're starting with someone that is a medium-sized shipping company. So I think we've all heard of Maersk and Costco, these enormous companies with thousands of ships. And in my experience, working with someone big like that is actually very difficult, because either they're big and they ignore you, or they come with 15 people and overwhelm you. And that's because that's how they are. That's nothing wrong with them. That's just the dynamics. So we have a U.S.-based, interestingly, company who we're working with, and we're going to start small. Start with a couple of ships, get on more of their fleet, get another person involved, and scale this up rather than just trying to do some kind of big bang.
What's the rollout? What stage are you at with the system that will kind of release the
We have an early design. We don't have any of the shipboard elements operating. We do have a partnership with another company who is separately installing system monitoring equipment on the boat so that we can give them our data and then use their satellite links to get it back to our headquarters. I mean, the systems are designed to be largely autonomous, but we of course want to know at all times what they're doing. The biggest partnerships that are important to us was, first of all, the work that my co-founder Rocio works on, which is reaching out to people who are not usually part of the discussion, because we're doing a project that is, everyone breathes, so it's for the breathing community, right? And usually those conversations are technocratic, or they're just, you talk to the people you know, and that's just part of an important value to us, right? Fundamental value to us, which is to be as much as possible, as to be fair, safe, careful, and have people know what's going on. There is an issue of international governance. We are working with a team who is developing an international governance, not just framework, but implementing a system for that. And we'll be one of the early companies to go through that process. Now, the other part of the outreach effort is that remember I said that you don't, often there's the underrepresented people are under or not represented, but there's an overrepresentation of people from the North, and a lot of those people are smart, knowledgeable, just nice human beings as well. And so we do also have relationships with some NGOs who are working on climate issues. As a for-profit company, we can't really have partnerships in the usual way with them, right? Because they're a nonprofit, and and each of them, of course, has their own goal, but the goals relate to what we're working on. Those are the kinds of communities that we participate with in order to make sure that, if someone has something to say that you didn't know, would you really be glad to hear it? So we're very careful to try to be as open to that as possible.
What's the business model as a for-profit company? How do you see yourself being sustainable? Can you talk about just the principle of the model?
Yeah, so that's right. So we remove some methane. We have some metering analysis and modeling that says by doing this at this day, in these environmental conditions, we can reasonably presume that 1 ton of methane was oxidized. And so how do we make money off doing that? So there is an infrastructure for carbon credits, and it's a very complicated infrastructure, but we want to get credit for the work we do, right? So, and what's interesting about it is that most of that field is carbon offsets. I'll plant a tree, I won't cut the tree down, therefore you can do this thing. But we're actually removing them, and there are people who are very interested in buying carbon credits that actually making a positive change rather than just failing to make such a negative change. And because of the instrumentation that we can do on what we're doing, we can make certain guarantees about these, that they really did remove 1 ton or half a ton or 3 tons or whatever it happens to be on this day at this time, so that they know that they're buying something real and not buying something just made up. And there is an infrastructure for cross-checking. Someone goes and validates what you've done, and someone looks at that and evaluates your process and issues it. So we are in discussions with that. Now those credits, okay. So about credits though, they have a poor reputation in some circles for understandable reasons because the quality of a lot of them is not good. Also because people feel, well, you need to get rid of the thing that emits the carbon. But I mean, if you're growing rice, you know, people need to eat that rice too, right? So what are we to do? Can we find a way to tie these two together? I did have a venture investor I talked to who...
Oh, sorry, can I just...
Yeah.
I'm just going to cut the files just going to get too long.
The device we're putting on the back of the boat is heavily instrumented. So we can tell when it operates on a given day, and there's measurement being made. So we can tell on a given day, this much catalyst was released, this was the environment it happened in, and 1 ton of methane was oxidized at that spot. There are people who are interested in buying offsets, methane offsets, similar to carbon credits, but these are actual removal ones. So you're actually doing a positive as opposed to forestalling something else. They're worth more both because methane is such a terrible greenhouse gas, something like 80 to 120 times worse than CO2, but also because of the fact that they're a removal and that we can give a very authoritative value. It's important to us that we use these credits, it's important to us that we offer these credits to people to help them transition or help them move forward and not just, you know, pass them out to the oil companies, for example.
And, you know, devil's advocate question, in supplying this solution, you're not promoting the continuance of a fossil burning thing. So
there is a position, I won't call it a widespread position, but you do encounter a lot. There is a position that if you repair the climate, then you're just taking the pressure off people to behave better. That's a lovely utopian vision. I would like to believe it myself, but I know that I live in the real world. And the fact is that if somebody builds a building today, it's going to be standing for 40 years, heating itself the way it was built. If you put a ship in the water, it's going to be transporting cargo for at least 25 years. So while people are struggling to work on new solutions to cause these things to pollute less, let's use the effort, the pollution that they are doing to fund this very important thing of reducing the amount of temperature rise. I would love it if there was no value in doing this. That's actually where I want to be. But, you know, I do live in the real world, and today there is value in it. And let's use that value to fund the work of making the planet a better planet for everyone.
Okay, my last, on a completely personal level, how you feel as an individual about the challenges of the planet and the work that you're doing.
We have an enormous amount of work to do. We, as humanity, have an enormous amount of work to do. And what caused me when I had that conversation with Peter, when I was getting this, when I had that conversation with Peter, I felt hope. Maybe we could do something. And I dropped all my other work, which was interesting work, to say, I really need to work on this because I am well suited for my background to work on this very project. And I wish to keep breathing for 20 years. I'm just being pretty frank about that. And what's been gratifying when I do talk to other people about what we're doing is people saying, wow, well, you feel hope. We didn't know it might be possible to repair the climate, right? And you know, then they say, you give me hope. And I'm like, great, why don't you work on one of these other problems? Because methane is just one, it's a terrible problem, but it's only one problem. And there's plenty of other problems to work to get the climate back to where it was when it really supported human life.
That's great. Yeah, thanks.